Okay, this is term 1, week 7, physics CA. Let me zoom out. Where is it? We're gonna start with the notes. Well, most of the material we have 2.17. It was recorded the notes, and 2.18 they were recorded uh, for the periodic. Only the new part is 2.19 and 2.20. I'll open here. Okay, OL sheet power. You have two new equations now. You know, all of you, that P equals oh, let me. Yeah. So you know that P equals IV. That's the first equation. We also know from Ohm's law that V equals Ri, or like from the equation V equals Ri. Instead of V, we can put R I, and it's going to become I times Ri, which is Ri squared. This is your new equation. And we also know from P equals IV that I from V equals Ri, I is equal to V over R, right? Instead of I can put V over R, and it's going to be V over R times V. So V squared over R. That's your third equation. And you know that power is work over time. So this is the first equation, second equation, third equation, or fourth equation. Okay, four equations for power. This question, it was CQD 50. Okay, what they told you is that you used an electric heater. Okay, and the voltage of the heater was 110, the current was 50, the mass of the electric heater was 100. It started at the temperature was 30 degrees Celsius. We want the second temperature, given that we left it on for 1 hour and that the C of it is 4.2 times 10 to the power of 3. In case it comes, it's not really part of the material, the MC delta T, but maybe he gets it in the final. Okay. But anyway, because some people might be watching this for the final exam, the notes, and he might get it in the AMS. What you have to do is that the energy gained by the object is equal to the energy lost by the heater, right? Or energy lost by the heater is equal to the energy gained by the object. Same thing here. So the energy lost by the heater is the power from the heater multiplied by the time, right? So power times time, because you know energy is equal to power times time. So power is work over time, or energy. We can say energy instead of work. You cross multiply, you get E equals power times time. So the energy lost by the heater is equal to the energy gained by the object. صح? Okay. What's the energy lost by the heater? Is power times time. We have here I and V. So instead of power, we're going to use IV, right? IVT. What's the energy gained when you're working with temperature? It's MC delta T, صح? Okay. Notice how I put Q here, just so like it's a bit easier for you to understand. Okay, and you just substitute all your values. Okay, the mass is 100. The time is 1 hour, so in seconds is 3,600. Mass is 100. C is 4.2 times 10 to the power of 3. Why did I put negative? It should be. I put negative 3? I think this is. I put this here by accident. Uh, I'm not sure about this. Just forget about it. Anyway, you substitute and you put, you know how it's delta t, so final minus initial. So final minus initial, question mark minus theta 2 minus 30 degrees. And you're going to substitute. Yeah, I think I meant, I don't know. Anyway, you solve this equation, you're going to get 3277. Okay, in case it comes. Okay, هلا resistance. Okay, there's the Joule's effect. Okay, la 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 la. Okay, this is just a question. Joule's law. What is Joule's law? Is that the heat liberated by a resistor is work or energy equals to power times time, right? And we know that power is equal to Ri squared, so they're just saying Ri squared times T. That's like, because they're talking about the resistor, you need to put it in terms of resistance. That's why they want by a resistor. Ri squared times T. It has to be this if you want energy by a resistor. Anyway, here's the system, yeah. Okay, resistors can be color coded. This is important. They didn't ask it in the quiz, but it was in the material for the book. Okay, and they may ask this. Okay, I think really he's gonna ask it. He didn't put it in the quiz for a reason, so he gets it in the exam. There are 10 colors ranging from 0 to 9. You start counting at 0, you end at 9, so that's 10 colors total. Black, brown, red, orange, yellow, green, blue, violet, gray, white. You need to know the number for each of these. So what they did is they made up I don't know, some sentence you memorize. Black beetles running over your garden bring very good weather. Uh, you can memorize this. Black beetles running over your garden black beetles running over your garden bring very good weather. Or the way I memorized it is black, brown, Roy, G, Biv, gray, white. Okay, that's how I memorized it. Black, brown, Roy, G, Biv, gray, white. Okay, why I memorize it like this? For those of you who don't know, Roy, G, Biv are the colors of the rainbow, and it's a famous thing, Roy, G, Biv, uh, which I already have memorized, and it's the colors of the rainbow. So Roy, G, Biv, I say black, brown, Roy, G, Biv, gray, white. You can do whatever you want, but this is the way they explain it in the book, and I just got the Roy, G, Biv method from me. Black, brown, Roy, G, Biv, gray, white. So basically, how it works is in a resistor, uh, you have four colors, okay? You have the first band, second band, the multiplier, and then the tolerance, okay? The tolerance is aside from the 9 colors here, or the 10 colors here. It can either be gold, silver, or no tolerance. Okay, if it's gold tolerance, that means plus minus 5%. Silver is plus minus 10%. No tolerance is plus minus 20%. For example, if you saw a resistor that's red, green, yellow, orange, gold, it would be equal to 254,000 plus minus 5%. How do you get this? Let me see here. Red. Okay, what are our colors? Black, black, brown, red, orange, yellow, green, blue, violet, gray, white. Or was it white, gray? It was gray, white, صح? Yeah, gray, white. Okay, what are our numbers? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 5. How do we do this? We have red. What's the number for red? 2. Green. What's the number for green? 5. Yellow. What's the number for yellow? 4. And then orange. This last color is always your multiplier. Okay, the last color is always your multiplier. What does that mean? That means you just add zeros. How many zeros do you add? Let's see. Orange is 3. That means I add 1, 2, 3 zeros. That's how it works. So you put your first color numbers, whatever. And for your last number, you add as many zeros as the number. So like orange is 3, so I would put 3 zeros. But if it was like, I don't know, blue for the last one, I would add 6 zeros. Okay, and then you say gold. What's gold? Gold is plus minus 5%. That's how it is. Okay, so if you go in the exam, you write down the table. Okay, and then they might give you a color, and then they'll tell you what's the resistance here. Okay, variable resistors. Variable resistors are called rheostats or potentiometers. Okay, rheostats are used to change the current. Potentiometers, from the name potential, is used to change potential difference, PD. Rheostats can either be circular or laboratory. Okay, this is yap. They don't ask this, but yani, I'll open the book for this one. Yeah, guys. So my ebooks isn't really working. Um. so I guess just open it yourself, but yani, it's just explaining the function, not even explaining it, just describing the structure of how it is. This is like the laboratory rheostat. It was too much for me to draw on my copy, so I just said see page 127. ما كان إلي خلق. But the rotary rheostat, this is just the app. Basically here, to function as a variable resistor, if you want the variable resistor, use Y and then choose either X or Z. But if you want it to be a voltage divider, just use all 3. Okay, and these are things you don't memorize, but if you see them in the exam as a multiple choice, you'd click them. You know what I mean? We're done. Let's actually do the quiz now. Here. Okay. They're very easy. I'm gonna fly through it, except the last question. It's kind of very easy, but you have to how can I say? You have to use your brain a bit. A straight cylindrical copper wire of length 1.5. So they give you L. Area given. Resistivity rho is given. What's the resistance? R is equal to rho L over A. Right? L. Okay. You're gonna do R is equal to the rho 1.7 times 10 to the negative 8 times the length 1.5 over 1.3 times 10 to the minus 5. This is how you put it on your calculator. You should get something. Okay, you should get something like I think it was 1.96 times 10 to the negative 3. Okay, they want it in milli. all the options are in milli. Milli meaning what do? You multiply by 10 to the power of 3. So your answer is going to be 1.96, and they just rounded it to 2. Okay? That's what I remember. I think that's what I got. Solved it a few hours ago. Okay. The main, okay, in experiment below, a rheostat connected in series. Okay, la 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 la. What is the function of a rheostat? Rheostat changes current, right? It's to vary current. At what point X or Z is the rheostat set for a maximum resistance? Okay, basically, how the rheostat works is you just slide this like up and down. You get what I mean? So I guess if you slid it all the way up, it's gonna like stop as much current. Because like, look, uh, actually, I don't know. I'm waiting for my ebooks to load. Okay, I think it loaded. Yeah, it ain't loading. Honestly, well, let's ask ChatGPT. Okay, yeah, just how I managed, but I wanted to say this, but I don't want to say something that was wrong. So they're saying point Z is at the far end of the resistive wire, meaning it would allow for maximum length of the resistor. And if you have a lot of length, it means the entire length of the resistive wire is included. Thus, you have maximum resistance. At point X, it's only a small portion of the resistance wire, so it's minimum resistance. Okay, and it's very okay. So if you put it on point Z, you can use the whole resistor. That means what's gonna happen? You're gonna have more resistance. If you point on X, you're not gonna use any of the resistor. Okay. Question 3. Okay, find the EMF if each one is 1.5. Okay, what did we say? It's here's 1.5. Here also is 1.5. But these ones, since they're opposite to each other, it's supposed to be positive, negative, right? This one's negative, negative. So what do? They cancel out, right? So you have 1.5, 1.5. So it's 3. Okay, it's not 6. Please don't put 6 or 4.5. It's only 3 because these two cancel out. Okay. Okay. The ratio of the potential difference to the current. So what is potential difference V over the current I? What's the ratio called? It's called resistance because this equals R, right? Uh, like I told you, very easy quiz, but it's the notes. It was like I feel like it's not gonna come like the quiz because there's a lot of stuff that wasn't in the quiz. What's the current here? If you have R and you have V, use R equals V over I. So I equals V over R. So 12 over 50, which is 0.24. Okay. Okay, the resistivity of germanium is 0.4. So they gave you the resistivity. They gave you the length. Okay, you need to make this into meters. So you put it times 10 to the negative 3. You cannot have millimeter, right? Okay, and the area of millimeter squared, 1 millimeter squared. Again, this has to be in meters squared. Okay, so you're going to multiply by negative 3, but you're going to square it because you have square. Okay, so now, what do you want the resistance? So R is equal to rho L over A. So it's going to be 0.48 times the length, which is 5 times 10 to the minus 3, over 1 times 10 to the minus 3 squared, so 1 times 10 to the minus 6. You're going to get 2,400, I think. And they want it in kilo ohm, so you divide by 1,000, you get 2.4. Okay. 7, the potential difference. Okay, find the power. P equals V squared over R. Remember this equation? Okay, it's one of the equations. There's 4 power equations. Let me go back to them fast. This is did I close the tab? I think. But it's these 4. 1, 2, 3, 4. P equals V squared over R. Why am I using this? Because I only have voltage, or I only have I only have resistance. So I'm going to use V squared over R, so 20 squared over 5, which is 80. What other answer could you put? 8. Okay, a current of 3 ampere flows in a 20 ohm resistor for 1.5 minutes. What's the energy displayed? Energy is equal to power times time, right? What's the power I have? Okay, the power in this case, I have current and I have R. So what equation am I going to use? R I squared for power times the time, 1.5 minutes. We need to make it seconds, so what do? We multiply by 60. Okay, so you're going to do 3 squared for the current squared times 3 squared. I put the resistance first because I put Ri squared. I put the resistance first. Okay, times 1.5 times 60. بيطلع لك 1000 something something something. It's 16 kilojoules, right? Let me do it just so. 3 squared times 1.5 times 16. Yeah, 16,200. Make it into kilojoules. It's about 16 kilojoule. Okay. Give the expression that relates the current across its V and resistance R. Okay, V equal Ri. Or you could say R equals V over I. Let's see here. Any one of these, right? Any one of these. You could say, yeah. Question 10. What's the resistance here of the ohmic conductor? R is equal to V over I. So this is a VI graph. Different to the one we were doing was IV graph, not VI graph. Anyway, so what you're gonna do, you're gonna take the slope. Let's just take 2 points. Take this one here, 0.1 comma 4 and 0.2 comma 8. Find my essential. So y2 minus y1 is 4 over 0.2 minus 0.1, 0.1. 8 minus 4 over 0.2 minus 0.1. You get 40. Question 11. A bulb has resistance 40 ohms, power supply of 5 volts, so they have V, they want current. Guys, these questions are very, very easy. I is equal to V over R. Okay, خلاص. V equals R, I take R to the other side, you get V over R. I know I take this extra step because some people, like, I write this formula for them. Even at this point in the quiz, they go like, how does this guy get this? Okay, so that's why I put the extra step because there will always be these people that always have no clue what's going on. Okay, V5 over the resistance 40, you can get 0.125, but they want it in milli. So what do? We times 10 to the power of 3. Some people go like, oh, wait, isn't milli times 10 to minus 3? Okay, yes, yeah, that's when you're going from milli to normal. But I'm going now from normal to milli. You're going from big to small, so obviously multiply, but from small, milli, to like normal, ampere, small to big, you have to divide. So you multiply by 10 to the negative 3. But in this case, I'm going from ampere to milliampere, big to small, so I multiply by 10 to the 3. You get 125. 12, okay, V, I, what do you want? Power? P, okay, uh, power. Power given I and V, guys, P equals IV. Wallah, these questions are so easy. 230 times 0.3, 69. Question 13. Okay, this is the question. I'm recording this the day before the periodic because I think he's gonna get this in the periodic. Oh, this finally opened. I want this resistors. Yeah, this is the color coding. There's a whole section for color coding, huh? So if he doesn't get from color coding, honestly, I'll be pretty disappointed, wallah. What I want, yeah, here. The laboratory rheostat. In this type of rheostat, the wire is on a tube with sliding contact on the metal bar. So you slide the metal bar, okay, and it will resist depending on how much you slide it. Okay, go left and go right. Okay, the rheostat can control currents of several amperes without being damaged, and the slider usually has a spring contact with the wire coil. The slider takes the current from the wire coils and passes it through a solid brass. Only terminals X and Z are used. This provides a fixed resistance. But if you use Y as well, it provides variable resistance. Rheostats are mainly used to vary the current, as shown in the next two experiments. في experiments بالوسطى. Oh, I didn't write this? Hmm. Are these not in my copybook? Yeah, I don't think this was October 2, October 3. I don't have physics October 4. Oh, okay. Is this required? MS physics. Yeah, 2.20. Okay. Like this, there's a problem. Like this, there's a big problem. Okay. Let me read over this and then explain them really quick. Okay. The first experiment here is the one that was in the quiz. They're saying just connect this, okay? Notice that the rheostat is connected in series. Okay, then they said move the slider and watch carefully what happens to the brightness of the bulb. Okay, they move the slider, why, right? And then what's the outcome? You have to know what they ask in the exam is the outcome. A rheostat can be used to vary the brightness of a bulb because it will what? It will increase or decrease resistance, which will decrease or increase current, right? And obviously less current, the less the brightness. There is zero resistance from the rheostat and therefore maximum current when Y is on X. Right? When Y is on X, there is zero resistance. The current in a circuit can be controlled by a rheostat. When a rheostat is set at maximum resistance, some current can be detected by the ammeter even though the lamp is not lit. If there is a maximum resistance, only some current will be detected by this ammeter here, but the lamp won't turn on. It's a very minimal amount of current. Experiment 2. Okay, basically here they use something called the voltage divider. Okay, it's not a rheostat anymore. Okay, and basically what the rheostat, what it's saying is that the voltage divider can actually reduce the current to zero in the ammeter. Okay, and they explain it here. A voltage divider is also known as a potential divider potentiometer. It is used more in electric circuits than rheostats. Uh, so they use usually the voltage divider more than the rheostat. The division of a voltage divider is smoothly variable and divides a fixed voltage into two parts, which when added equals the fixed voltage as shown in the diagram below. So this voltage divider, it started at 4.5 volts. Okay, they got the voltage divider, and basically this slider Y, they moved it up, so there's more volts here than here, and they always add up to the one here, right? Let me see what else do they say here. Good thing that my ebook's loaded, guys. Okay, so I just realized that okay, I'm obviously it's in the when you're watching this, it's not gonna be in the video, but I recorded 2.21 by accident. I didn't know this is a 2.21. So I'm gonna delete this from the drive. Uh, and I'll re-upload it as 2. Ya Allah. Okay. خلاص, it's fine. After this, after the voltage divider, there's nothing. Okay, so I just went over what was not in the. Okay. Power is transferred from a lamp 23 meters away. So they gave you the length of the copper wire. It's a cylindrical copper wire. The resistivity is 1.72 times 10 to the minus 8. So they gave you rho. Okay. Uh, and the maximum resistance is 0.1 ohm. So they gave you R. They want the diameter of the copper wire. This is a trick question. What is the equation? R is equal to rho L over the area. In this case, it's a cylinder. What's the cross-sectional area of a cylinder? It's pi r squared. And can we find the diameter if we have the radius? Yes, we can. So let's just find the area. Okay, the radius is the resistance is 0.1. The resistivity is 1.72 times 10 to the minus 8. The length is 23 over the area. Okay, can we find the area? Let's just put it in my calculator quickly. 0.1, 1.72 times 10 to the minus 8 times 23 over, we call it x, shift solve, you get this. 3.956 times 10 to the power of negative 6. So A equal to 3.956 times 10 to the minus 6 equals pi r squared. So let's divide by pi. So divided by pi, we're going to get this. And we're going to square root our answer. We're going to get this. Okay, so this is our radius. Okay, what do? We want the diameter. So what we're going to do, we're going to multiply by 2. Because, the diameter is double of the radius. Okay, you're going to get this. And they want it in millimeter. So we multiply by 10 to the power of 3. Since it was originally meters, we want it in millimeter, big to small, multiply. You get 2.24. Okay? Some people might not get the diameter radius part, so that's why I wanted to mention it. Anyway, now, thank you so much for watching, and good luck.